Hello class and welcome to today's lesson on 1.7. We're going to be talking about tree diagrams. Our objective today, students will be able to create tree diagrams to model outcomes. And then our essential question is, what does each branch represent? So to start here, looking here, this is an example of a tree diagram. It actually has 3 levels to it. So it says tree diagrams help us list the different outcomes of multiple events. If we notice this one, what this is we toss a coin once, we toss it a second time, we toss it a third time, and we're showing all the different outcomes we could have, right? One example is that we get heads all 3 times, right? Heads, heads, heads. We get heads, heads, tails, so on. We can get tails, heads, tails, and then of course tails, tails, tails. So, right, what a tree diagram helps us do is figure out all the different possible outcomes we could have by the end of certain events happening. So looking at this example here, right, we're starting by flipping a coin, and then we're spinning a spinner that is either red, yellow, or green, all equally likely here. So what we're going to try to figure out is, what are these 2 missing options? So if we notice here, they're kind of in order, right? We have tails green, which is down here, tails yellow, tails red, so that's all the tails ones. Now notice we have heads green. So if we notice, right, we're missing 2 options here, and right, we can check those by seeing heads yellow and heads red. A good way to check how many options you have in the tree diagram is by counting the last step. That's always going to be how many total outcomes you have. So in this case, 1, 2, 3, 4, 5, 6, right? We have 4 here, and our other 2 right there is heads red, heads yellow. So looking at this outcome here, hold on one sec, expand this. So taking out the tool here, right, we look at this, right, we have a spinner 1. Spinner 1 has numbers 1 through 3. Spinner 2 has numbers 4, 5, and 6. And we're talking about all the different outcomes, right? We got to fill in the missing ones. So I'm going to do my best here. Actually, we'll just type this part in. So if we look at this outcome, right, it starts with a 2, and then spinner 2, we get a 5. Now in this outcome, right, it starts with a 2 on spinner 1, and then we get a 6 on spinner 2. Some space here. And then this one down here, notice our first spin was actually in number 3, and then our second spin was spinner number 4. So now we have all of our possible outcomes filled in. So what we're going to do is we're actually going to fill one out completely here. So to start, so tree diagram, right, another helpful way to see all of the outcomes. Useful when looking at the amount of outcomes for multiple events. To draw a tree diagram, a couple steps here, right? We draw a dot for the start, so we always have a beginning point. Then we draw lines out from the start for the different events. So notice this one is already made for us, so we can copy this one down. But our example is we're going to flip a coin, and then we're going to roll a 4-sided dice. So I'm going to do here, right, if I'm flipping a coin, we got to think about what are our possible outcomes. Or if we flip a coin, we could either get heads or tails. And now if we're flipping a 4-sided dice, we have 4 options, right? We have either 1, 2, 3, or 4. And right, not only do we have those options there, but we also have the same options down here. So 1, 2, 3, and 4. So now we've filled out our tree diagram, and right, we can always count how many total outcomes there's going to be, right? by counting these last branches, we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 total options in this case. So going on to our next example. It says, suppose you have a bag of marbles. There are 12 blue marbles, 10 yellow, and 4 pink. Pick a marble out of the bag, keep it, and pick another marble. Draw a tree diagram for this scenario. So we're going to fill this out. Right now, what we're just worried about is, can we fill out a tree diagram? Dealing with the numerical values we'll get to, and that's a step that will be useful down the road here for later on. So we are going to practice it, but as long as you can understand how to set it up, that's what's key. So right, our 3 options to start with is 1, either a blue marble, a yellow marble, or a pink marble. And then we are then going to go out and pick another marble. And so off of each of these, blue, yellow, pink, I'm actually just going to copy these to make it a little easier here. Blue, yellow, pink. Click all those, we'll group them. Now I'll just drag this here and down there. So if we're looking at this, our options, blue marble on the first draw, yellow one or pink one, and then from there we could have either blue, yellow, or pink other options. Real quick, just to go over numerical values here, for our first marble, we have 12 options of blue, 10 yellow, and 4 pink. So now we're going to go off the fact that we picked a blue one our first try. So if we picked a blue one our first try, notice we now only have, for our second marble, 11 blue to choose from. But if our first one was blue, we still have 10 yellow and 4 pink. Okay, now we're going to do it based off of what if we got a yellow the first time. All right, we got to think back to the very beginning. If our first marble was yellow, that means we still have those 12 blue. But now our yellow is down to 9, and our pink is still at 4. And last one, again, repeating this process, 12 blue, 10 yellow, but now our pink, since we already chose one, is down to 3. So right there is an example of tree diagram, filling it all the way out. Again, notice, or what's important is, can you figure out the letters that go there, the process there? The numerical values is something we'll practice, and it's going to be more important once we get to chapters 2 and 3. So looking at this example, it says draw a tree diagram for picking a face card, keeping it, and then picking another face card. So if we think about our options, we either get a face card, and if we don't get one, then it's not a face card. Then again, once we picked a card, we again either get a face card or not a face card. It's a little easier here. Not a face card. And then down here, same thing, we either get a face card or, oops, excuse me there. Oh, sorry about that. Delete that one. Or not a face card. That's right. That is our options. That's how we'd fill it out. Again, numerical values. We can think about this one. Face cards is talking about jacks, queens, and kings. And so there's 3 for every suit, a total of 12 cards. So if there's 12 cards that are face cards, that means there's 40, because a deck of cards is 52 cards, 40 cards that are not face cards. Again, process is the same. This numerical value part, not as important as just understanding, can you fill in those pieces there? So I'll fill this in, 12, and now this will be down to 30. So we'll do the next couple. I'm not going to worry about the numbers anymore. We're just going to kind of run through quickly. Can we fill in these tree diagrams? So that one's actually a repeat. So this one says draw a tree diagram for picking a heart and then keeping it and picking another heart. So right, our options here is we either pick a heart or not a heart. Now, this is going to be the easiest way to fill in tree diagrams. So right here, then again after this, we could either get a heart or not a heart. And then same thing down here, we could either get a heart or not a heart. So again, if you're understanding this process of putting the actual words from each branch, that's what we're focused on today. So now this one says draw a tree diagram for flipping a coin twice. Right, we have to think about the outcomes for flipping a coin. We either have heads or tails. So now again with this, we think about, okay, well, what are our possible outcomes? Well, with heads, right, after we flip heads, we could either get heads again, or we could get tails. And our second flip after we get tails, right, we could either get heads or tails. So that is it for today, talking about tree diagrams here and 1.7.